A warm welcome to all present here. Myself, Gurinder Pal Singh. Hope you all are fit and fine. Well, this is my third video on the chapter Force and Laws of Motion of Class 9. Dear students, this video will cover the meaning of Newton's third law of motion and the applications of Newton's third law of motion. So students, without wasting any time, let's start. Well students, it is a common observation that when a body A exerts some force on another body B, then body B also exerts some force on body A. Let us understand this fact with the help of example. Let us suppose when a player kicks a football, the football moves forward and the foot of the player moves backward. Dear students, the force with which the football is kicked by the foot of the player is known as action. Due to this action force, the football moves forward. On the other hand, the force exerted by the football on the foot of player is known as reaction. Due to this reaction force, the foot of the player moves backward. Students, action and reaction forces are equal in magnitude but opposite in direction. However, action and reaction act on different bodies. The acceleration A is equals to F upon m of the football is much more than the acceleration of the foot of the player. This is because mass of the football is much less than the mass of the player. Next example is when a ball falls toward the earth exerts a force F1 on the ball to attract the ball towards its center. On the other hand, the ball exerts a force F2 on the earth to move the earth upwards. These two forces are equal in magnitude and opposite in direction and form the action-reaction pair. Dear students, the upward acceleration of earth is not noticed because the mass of earth is very large. So students, from these examples we conclude whenever two bodies interact with each other, they exert equal and opposite forces on each other. Out of these two forces, one is known as action and other is known as reaction. Students, second conclusion that we have drawn is action and reaction act on two different bodies interacting each other, means influencing each other. Let two bodies A and B press against each other as shown in the diagram. Let F1 be the force exerted by body A on body B and F2 be the force exerted by body B on body A. Then F1 is equals to minus F2. This relation shows that F1 and F2 are equal in magnitude but opposite in direction. Students, the force applied by body A on body B, that is F1, is known as action, while the force experienced by body A due to body B is known as reaction. So students, statement of Newton's third law of motion is, to every action there is an equal and opposite reaction. Students, action and reaction act simultaneously and they act on different bodies. Let's have a look on the numerical. A boy weighing 30 kg is sitting on a chair. How much reaction acts on the boy? Students, as we know that action is equals to weight of body on the chair in the downward direction, that is equals to mg, that is 30 into 9.8, that is equals to 294 Newton in downward direction. And we know that reaction on the boy is equals to minus action, that is 294 Newton in the upward direction. Now we will study some illustrations of Newton's third law of motion. Students, can you tell me, when a body is dropped from some height, it rebounds after striking against the floor? Can you tell me the reason behind it? Yes, let me tell you. When a ball strikes against the floor, it exerts a force known as action on the floor. According to Newton's third law of motion, the floor exerts an equal and opposite force known as reaction on the ball. Due to this reaction, due to this force, the ball rebounds. My dear students, do you know how Newton's third law of motion helps us in walking? Well, when a person walks on the ground, he pushes the ground with his foot in the backward direction by pressing the ground. This push is known as action F. According to Newton's third law of motion, an equal and opposite reaction R acts on the foot on the person. The horizontal component H of the reaction R helps the person to move in the forward direction, and the vertical component of V of the reaction is balanced by weight W of the person. Students, do you know how Newton's third law of motion helps a swimmer to swim? Let me tell you. A man pushes the water backward with his hands. This force of push on water is called action. According to Newton's third law of motion, the reaction force offered by the water to the man pushes him forward. In the similar manner, a boat moves backward when a person jumps out of the boat. The reason behind it is when a person jumps out of a boat, he pushes the boat in the backward direction, that is action. According to Newton's third law of motion, the boat exerts an equal force, that is reaction, on the person in forward direction. So, when the person jumps out of the boat moves backward. Students, we often observed that a boatman pushes the river bank with a bamboo pole to take his boat into the river. What is the reason behind it? Well, students, when the boatman pushes the river bank with a bamboo pole, the river bank offers an equal and opposite reaction on the boat. This reaction helps the boat to move into the river. Students, it is a common observation that it is difficult to drive a nail into a wooden block without holding the block. Do you know the reason behind it? Same Newton's third law of motion is applicable in it. Well, when we strike the nail with a hammer without holding the block, the nail and wooden block both move forward as one system. On the other hand, if the block is rested against a support, then the reaction of the support keeps the block in position and nail is driven in when struck by the hammer. Well, students, principle of launching of rocket is also Newton's third law of motion. The gases produced in the combustion chamber of a rocket engine come out of the rear of the rocket in downward direction, and the reaction of these exhaust gases pushes the engine in the upward direction. Now, let us consider two spring balances connected together. The fixed end of balance B is attached with a rigid support like a wall. Students, when a force is applied through the free end of spring balance A, it is observed that both the spring balances show the same readings on their scales. It means that the force exerted by spring balance A on balance B is equal but opposite in direction to the force exerted by balance B on balance A. The force which balance A exerts on balance B is called action, and the force of balance B on balance A is called reaction. This is how Newton's third law of motion is applicable in this situation also. Let's move on to another example. Suppose when a gun is fired, it exerts a forward force on the bullet. Then the bullet exerts an equal and opposite reaction force on the gun. This results in the recoil of the gun. Since the gun has a much greater mass than the bullet, the acceleration of the gun is much less than the acceleration of the bullet. Students, this is how Newton's third law works when a gun is fired. Now students, very interesting question arises that if action is always equal to reaction, then how a horse can pull a cart? So students, let me clear you. Actually, a horse pulling a cart pushes the ground by its feet backward at some angle. In turn, the ground exerts an equal and opposite force in the opposite direction on the feet of the horse. Students, the horizontal component of the force F exerted by the ground makes the horse move forward along with the cart. This motion is opposed by force of friction small f between cart and ground. acting in backward direction. If capital F is smaller than small f, then cart will not move. If capital F is equals to small f, cart will move with uniform speed. But if capital F is greater than small f, then cart will move with accelerated motion. Let me tell you the meaning of small f and capital F again. Capital F is a horizontal component of force exerted by the ground, and small f is the force of friction between cart and the ground. Well students, these are few applications of Newton's third law of motion. Hope you have understood the concepts very clearly. Hope you have enjoyed this lecture very much. Thank you so much students. Goodbye.